Thank you for coming.
Thank you. Okay. Okay, thank you for the kind invitation. It's a pleasure and an honor, of course, to be here and especially being the opening keynote in this event. It's kind of a challenging thing to kind of think about what would be the right content, and because when looking at the program, I expect that we will have very good examples of projects that have been succeeding. I'm focusing more on the challenges of kind of really how to link the BIM into the building of smart cities. It's quite obvious that there is quite strong connection between the BIM, but it's just part of the whole picture of digitalization of our industries. And I want to start a little bit about my background. And the reason for that is that because there are much younger people in the audience, I want to emphasize some things that are quite, I would say, not very typical in my career. First of all, I have been working about 26 years in the industry and about 26 years in academia, partly overlapping because my working career has been about 46 years now. And I retired about a year ago. And one of the things that I'm emphasizing in that picture is really that kind of that turning point on my career was in 1997, when I was invited to lead the national BIM program in Finland, a 6-year program, total budget of 47 million euros, consisting of more than 160 projects, and it was leading to the first kind of I would say the first adoption of BIM in the industry anywhere in the world. It was a big investment, but it was really a change also in my personal career, because before that I had been only working in Finland and mainly being an architect. I had been doing some software development, but not really serious research before that. And suddenly I was leading the biggest BIM program in the world, traveling around the world, speaking about the topics. And one incident was that I want to emphasize was that in 1996 in May, we had the founding meeting of IAI, which is now known as Building Smart. And I was sitting there next to the technical director of Kashima, which was the biggest construction company in the world at that moment. And I was coming from a company with 2 employees and myself, so 3 people. And my feeling was that I'm in the wrong place now. But then I was elected to be the first international chairman of Building Smart. So obviously I wasn't in the wrong place. But it's kind of one of the things that I want to kind of emphasize here is really don't plan too much about your career, because you can't expect something that you can't imagine to ever happen. And I have had several turning points in my career that have been that way. And also, don't be afraid of new challenges. It's really something that you have to have the courage to really jump to something unknown to be able to achieve something. Also, one thing that I want to emphasize here is really when thinking about that kind of my career, that I have been now in the business of trying to change the construction industry for more than 30 years. The change has been much, much slower than anybody expected 25 years ago when we started Building Smart. But it's just something that you have to accept that it takes time to make big changes in the environment. But you have to really have the courage to still kind of going on, because it's really rewarding now to see that some of the visions that we had 25 years ago are becoming reality in the world. So I will start with some aspects of BIM that I think that are crucial when thinking about the value of BIM for the smart cities. First is really what is a model? This is a very fundamental question, because there are lots of misunderstandings about what the model of the smart cities could be. And this is the first example here is a process model. Then mathematical model, scale model, fashion model, or BIM. Why we are calling them all as a model? What is really the thing that it's making them as a model? And the best definition I have ever found for that is from the artificial intelligence, quite old one, kind of in 1989, that model represents reality for a given purpose. The model is an abstraction of reality in the sense that it cannot represent all the aspects of reality. And this is very fundamental. Model is always a simplification of the world. We can't model the whole world. And when thinking about kind of the smart cities, we are speaking about very complex models. Actually, really, we are not speaking about one model. We are speaking about connections between the different models, which is very fundamental. It's also, when speaking about the individual buildings and the traditional view of BIM is that kind of, it's by definition, it means that the models that, for example, architects, structural engineers, construction companies or facility management are handling, because they must be different because they have different purposes. We can't imagine to have one model of the building that would cover all these tasks. It would be totally unusable for the tasks. And when we want to share the information, we have to define the shared information or shared data in a way that it's kind of really possible to handle in the different software products that we are having in our environment. And that's a really challenging task. And of course, when we speak about the built environment in general, the smart cities is becoming even more challenging. And then also one aspect that is really important is that we have a very different models, but also level of abstraction and level of detail is changing. The most abstract definition of GIS is really this spatial network model, which is really has nothing to do with our built environment. It's very high abstraction. Then when we think about the typical map views, the road network models, it's more like kind of a human readable model already. But behind that, really, when you use the GPS in your car or in your phone, it's behind that is really this high abstraction model of the network model is there. But then when you move to city GML, the first level of detail there is very, very high abstraction. Again, it's like map. Then you go to, for example, level 3 and level 4 are basically more or less the same as BIM. And also when we speak about the BIM, we are speaking about the LOD, which can mean either level of development or level of detail. To me, it's level of development is something which is developing through the time. So it's kind of, we know more about the more details about the models in later stages. But also the level of detail, the different levels of detail can live at the same time as they are living in the city GML. It's really important that they are not replacing each other. They have different purposes which we need to use. But one of the really common, very common misconception has been that the ultimate goal would be one model. It's never going to happen, and unfortunately I have to say that we in Building Smart made one communication mistake with this image that I suppose that everybody has seen several times, because this has created kind of the illusion that people think that we would be aiming into one model where everybody is working. So some people think that the ultimate goal for BIM is something like this, that we would have a central database where everybody is working. And unfortunately, this is not possible, because really the definition, what the model is not possible to think. So I would say that forget the idea. But this was, for example, leading in the development of BIM requirements for the government in the UK for a long time. I was all the time struggling with them in the meetings when I participated to kind of with that goal that the ultimate goal would be one model. So basically, what BIM is we will still have, and we will always have, the sub-models which are for different purposes: architectural, structural, MEP, construction, facility management models. And we are having the shared information, shared data that we are kind of extracting from our models. So we are updating the shared data based on the working model that we have. And we are then referring to the information of the other models but we are never taking back our own information from that shared model. It would be ridiculous to think that kind of there would be one central model which kind of would be steering the models that we have in our tools, in the software that we are using. And the integrated BIM means that we are kind of having this infrastructure in a way that where the different models are linked together. They are communicating with each other, they are sharing the data, but only the necessary data for the activities that we have there, which is also very fundamental when we think about the value of BIM in smart cities. So it's more like kind of I think that this image from Leon van Berlo, who is now the technical director of Building Smart, is kind of, this is much better illustration that we are trying to reuse the interfaces. It's a little bit similar thing that I'm speaking now here English for you. Of course, I could speak perfect Finnish, but it would be much more challenging for the translator or kind of, and probably there wouldn't be anybody in the audience that would understand my language. It's the same way that we have the common language, like nowadays English is more or less the lingua franca, so we can communicate, and it doesn't cover all the final details that we have in our native languages, but it's still much more useful for communication than having something that you can't understand, but it's a perfect description, which fits totally to the kind of idea of the models as well. Also, one thing that I want to kind of, one misunderstanding that I want to correct is here, that I have seen several scientific papers about this kind of, that people are having, they test the validity of IFC by using that kind of, that they have the native model, whatever software you have, you are exporting the file in IFC format, and then you are importing that back to the same software that was exporting it. And then people are complaining that IFC doesn't work because it's not the same model anymore. It's not the same model. It's really, you can't edit that. But what is really the purpose of that? Is that kind of it's not trying to replicate the original model that you have for different purposes, but it's really the basic idea there is that you have really the parametric model which is in your working environment, in the software that you are using in your tasks. And then you have static model that you are exchanging as a shared information or shared data between the different applications. And that is very fundamentally different thing. So the question is that, does it cover all the information that you need for the tasks that are kind of using the shared model? That's a crucial question. If something is missing, we have to improve that. But the claim that IFC is losing data is totally absurd because the original data is still in the original model. It doesn't disappear anywhere. But the question is that, does IFC carry all the information that you need to carry to do your tasks? That's the fundamental question, but it's not going to be the same idea. And then, of course, the one question is that, why would you do that? Really, it kind of forget kind of bringing your own data back to your original software. It doesn't. That's not the purpose of the IFC or the data transfer. It's a little bit like kind of that, if you think about kind of having some excellent novel, like, for example, Gabriel Garcia Marquez's book, and kind of you translate that in Finnish. And kind of bringing back the IFC is like kind of translating the Finnish version back to Spanish and expecting that it would be as good book as the original was. It's ridiculous. And of course, most importantly, what would be the business case for that? You already have that. And the same way, the IFC is kind of it's not the replication of the original model. You have all the data in your original model, and the shared model is for another purpose. It's about communication. The same way that, unfortunately, I'm not able to read the original version of Marquez's book, but I can read the very, very good translation that it's in Finnish. It may be not carrying all the same nuances, but it's still much better for me than trying to read Spanish. I would have to be really, really good with the language to be able to kind of understand the book the same way as a good translator is doing that. And the same way, this is also very fundamental when thinking about the purpose of IFCs. So, but then moving from, now we are using BIM mainly for individual buildings, but then kind of when we speak about the smart cities, we really need to kind of connect the data. And this is something that it's now, the current definition of level 3 BIM in UK is about the smart cities. It's really about connected data, connecting the pieces together. And when the development of UK BIM requirements has been moved to the Centre of Digital Built Britain, which is now in the University of Cambridge, kind of one of the trends there, as also globally, is the national digital twins. There will be several talks about the digital twins as well here later on. So it's an ecosystem of connected digital data or digital models, enabling the better decision-making across the built environment. And when we think about that, it's really of course, the fundamental reason is that kind of we try to get benefits for the society, benefits for the economy, benefits for the businesses, and benefits for the environment. So that is the driving force behind trying to connect these different things. But when we think about the digital environment, or our built environment, it's consisting from several systems. We have, for example, transportation, energy, water, telecoms. We have waste management there. We have the social infrastructure. We have also the residential, commercial, and industrial environment there. And also we have the natural environment, which is part of the built environment as well, because we can't really think about the cities without the parks as well. So everything is kind of connected when we think about our environment. And really the built environment is a very complex thing. And at the moment, BIM is mainly covering the individual buildings for the different purposes, but it's slightly kind of now moving into the built infrastructure, but still very, very, very little coverage in that. But when we think about what is then the digital twin, it means that we have the physical things in our environment. And then the digital twins are basically kind of a digital representation of that thing. And we can think that the data can also flow from the physical things. Like, for example, the building's behavior can be linked to the digital model so that we know how much energy the building is using at the moment and what kind of a temperature we have in different rooms and so forth. And then we can use the digital model to make kind of interventions in the physical world. And that's the basic purpose. But when thinking about this, already this linkage on individual objects, it's quite challenging. But it becomes much more challenging when we think about kind of a connected digital twins. That, for example, if we think about train, connecting that with the railroads and the communication systems in there, then you have kind of really the connected digital twins. You have some kind of a system that it's connected. Then you can start connecting, for example, the railroad systems, the flight systems and bus systems. Then you have ecosystem of connected digital twins. And then when kind of you connect the different ecosystems in different areas, for example, the transportation with the energy or with the water, then kind of you start getting more and more information about what happens in the, and everything is connected in the physical world. The question is that how to connect them into the digital world. And then basically the goal is to cover all these different aspects of built environment in our digital environment. And the basic principle of that is this which is called the Gemini principles. So the purpose, there must be a clear purpose for these models and the twins. It must be trustworthy. and it must function effectively. So these are the metrics that are used for the kind of an evaluation of the systems or the connections if they function correctly. And the digital built Britain or any kind of a digital built environment is really the connection of the different things. It's covering the design, also planning, of course, buildings, operations, and then the integration of different systems. It's a very complex thing. But when thinking about kind of how to go there, trying to predict the future is always a little bit challenging. But I will kind of point out some of the challenges that we have there. First of all, to defining purposes and content. What do we want to do with the digital twins? And what is the data that is needed for those purposes? But we have to start from the really why we want to do it. What is really the purpose of the digital twin? What we want to do with that? Unless we can define that, it's impossible to define the data content. Also, the trust is not a simple thing. Who is maintaining the digital models? Who is making sure that they are up to date? Because if they are not up to date, you can't trust on the information there, and you can't use them, really. And then, of course, the functions that kind of, how many twins do we need? I don't think that it's in any of the areas, it's only one digital twin, because there are so many different things that we want to do with the models. And how to connect those different twins together, how to build that connections. And it's even more complex than that, because we do have also product libraries, we have the city models, we have the codes and regulations, we have the traditional BIM, and we have the facility management. We have a lot of different sources of data and information, and how to connect that together. It's a real challenge at how to do that. And one of the challenges is that kind of how to access the data. If you think about the current software, very often we have a situation that we have this monolithic approach. These are from one of my friends, developing these modular approaches. And if we think about the kind of if the data is locked inside the application like we have now, you can't have access to that easily. The question is really the kind of that we should be able to free the data from the applications and build a data service level, which is then making it possible to access the data that is needed for the different purposes, and of course also that you have the right to see that data. Not everything is shared. But that is one of the things. And that means that we can then use that data source for different purposes, have the relevant data for the different tasks that we have in our environment. There are lots of different roles that we need to combine in these. And then also we have a lot of different devices. And how to kind of show the data is one of the challenges as well, because you can't kind of replicate the display that you have on a computer on the phone. You have to have the relevant information that is useful for the task and useful for the device. But really the basic thing there is the first step is that you have to really open the access to data, build the modular applications. But this means also that we have to move on from the current IFC, which is based on step technologies. We have to move on, because really kind of now what we do when we are comparing, for example, in the integrated BIM environment, when we are comparing the different models, recognizing what is the same object, for example, the column in the architectural and the column in the structural model, is based on the location. There is no link between them. It's kind of impossible for the computer to really know, are they the really representations of the same object. But this is something that kind of where we are now with the IFCs. Then there has been quite a lot of effort to try to build the metal servers. But the problem there is that it's really it makes the kind of the central as the master. So the model that you have on the data server becomes the master. And it's very difficult to manage that environment, the changes that are all the time made in the design and construction phases and also in the operations. And then the third possibility is to really go to the linking, which is very flexible. It's kind of keeps the native as the master, but it requires quite a lot of infrastructure. And this is a challenge. This is from one project of Seppo Törmä from Aalto University. He was the first one that was proposing this linked data in architecture and construction. And now it's part of building smart development as well. And so I think that this is really the route where we are going, that we have to think about how to link the different models, or the data in different models together. And when we think about that, we have a lot of goals, a lot of purposes that are necessary for the efficient work, and we have then requirements that are coming from the goals. And how to approach that is when we think about the web of data, it has already a lot of infrastructure built for other purposes, not for the built environment necessarily. But it's providing the platform and the possibilities for technical solutions. And especially this part of the structural data is very interesting when we think about how to move to link the different individual pieces of data in different models together. And when thinking about this change, is first a positive thing about this is that it's moving from the very rigid, very old-fashioned step technologies in more modern and flexible technologies. The software houses now are struggling to find people who understand the step. Step was created in 1970s, 1980s as the product model standard. And when you think about the development of computers from that time, it has been huge. So there are no universities really teaching the step technologies anymore. So the programmers are not familiar with that, but they are very familiar with the web technology. So it makes it much easier to make the implementations if we move on. Also, it's providing much more functionalities than the current IFCs. We can have really the reasoning, database description, linking and queries, and access from to the different data if that is freed from the original software. And also, one very important part of that, building on top of the structure that has been defined in the IFCs. Because there has been more than 20 years work in that. If we start from scratch and forget everything that we have been doing so far, we are basically going back in the history, and it will take long time before we can build the same logic. So this is really fundamental, that we should never forget everything that we have done in the past, but really build on top of that. I have been now speaking about in a way that it you might have the feeling that it's this is impossible, it takes so long time to be able to do that. But it doesn't mean that we shouldn't or couldn't do anything today. Just as an example, I take a couple of projects which are from the digital group, which is Paul Doherty, one of my very good friends, sent me the slides. And these are, of course, just a very small glimpse of the project that they are doing around the world. They are doing a lot of smart city development. And the first thing that I want to emphasize from here is that it's not a marketing campaign or some sales technique or some amusing political catchphrase. Smart cities are really necessary when we think about how to solve the problems that our society and the world is facing at the moment. We have to take them seriously. And we can do a lot of things. BIM has a central role in their project, even though we don't have all the features that I have been talking so far, but still it's useful as the basis because it's providing really the basic information for that. And this is just one example of a bus system that is based on using BIM, using the digital twin technologies. They are connecting already the things. So it's not just something that will happen in the future, it's already done today. But this requires at the moment that the projects that are doing this, they are pushing boundaries. They require very high technical abilities to do the things. And if we want to change the construction industry, we have to make it simple. And that's why we have to develop the standards, we have to develop the things that I was mentioning before. Because we can't expect that every project will have information technology experts who are able to do the things in the current environment. But you can do them, and it's necessary that we do them because they are also providing information how to do that for the future. So these were some of the things that Paul wanted to kind of address there. That first of all, that using the BIM data is giving really the geolocation for the objects. Also, they are using the game engines, which are really very, very advanced at the moment because they really are useful for these purposes. The standards is really fundamental for the success of BIM data being used. Because really, as said, that kind of even though you can do it now on a project level, but it's very challenging if we want to change the industry. And also that when we think about the different industries, they have very different requirements for the digital twins, sometimes even conflicting requirements. And I think that I really like the last point there, that treat data like an element, like water that can be ice or liquid or steam. So data can be used for different purposes when we manipulate that. So that's one of the things that we really have to think that what is the model where we put certain part of the data, what is the best location for that, and how we can then utilize that in the different applications that we are building around the things. And then my last point is really that we must really define where we want to go. And this is something that it sometimes, when I have been now working in this area for more than 30 years, sometimes I have a feeling that we are just drifting. We don't have really kind of very clear plans what to do and what to try to achieve. But we have to remember that technology is not a force of nature. It's not like kind of a flooding or a tsunami that it's just coming. It's something that is man-made. And when it's man-made, we can define and we must define where we want to go. And one document that I have really been reading with quite great interest is this Built Environment 2050. It was done in the UK already almost, I think, about 5 years ago. And I don't believe that anybody knows where we will be exactly 30 years from now or more than 30 years from now, because thinking from the past, we didn't know 30 years ago where we will be today. And the same way, we can't predict the future exactly. But still, I think that it's very important to have a kind of a discussion where we want to go. Because if we don't really think about where we want to go, then as kind of on my last slide is about from Alice in Wonderland, that if you don't know where you want to go, it doesn't matter which path you take. If you really want to have a certain type of future, we have to define where we want to go. Not exactly, we don't exactly know the path, how to get there, but we know that this is the goal where we want to go anyway. Thank you.